we mentioned the last part mentions function notation. So this is another term that you must understand. So function notation is how we write functions. Okay, what symbols we use, what order they come in as such. So any equation that is also a function can be represented using function notation. Okay, for example, y equals 2x squared is an equation. Now, if we want to write that using function notation, let me just get that. Instead of writing y, we write f bracket x. And the way that we say this part, we say f of x. So a function of, the f stands for function. So what we're saying is this is a function of x. And so we call, when you write an equation using f of x, we call this function notation. So it means the same thing, but now you're taking an equation and writing it as a function. So just to be clear, you can have an equation that is not a function. So y squared equals x is not a function. Okay, so as such, I cannot write this in function notation, because when I write an equation in function notation, I'm saying this is definitely a function. Okay, and what we're saying is that the result of this equation, so whatever we get here, which usually is a y, is a result of the function. Okay, let's keep talking. I remember, so you might be fine, but I just remember being in high school and seeing function notation and not being able to comprehend why or what the difference was. So if you're struggling to understand this, the idea of function notation, ask questions, ask me, Google it, right? Make sure you understand why we're using it. So the reason why we write it as f of x is because the value of y, right? Y depends on x. Remember we said that the y is, the variable is the dependent variable and it depends on whatever the x is. Okay. The value of y is a function of the value of x. Okay, so the value of y, whatever number we get for y, is a function of x. Let's go back to the function machine. Remember we had the machine that gave us a certain number of steps and we said, what's the rule? Well, actually, instead of calling it a rule, we call it a function. Okay, and so what goes into the function machine? What's the input? Well, that's the x values. And what comes out? Well, that is the y value. So you might have a function, something like this, 2x minus 5, right? So you put in an x. Okay, let's say x is 1. 2 times 1 minus 5 is negative 3. And it spits out, oh, y is negative 3. So do you see how y is not independent? It really depends on whatever value you give x. So we're saying y, the output, is a result of or is a function of x. Okay, lots of words. Another way of looking at it is like a machine. So you input something and it outputs something else based on what goes on inside the machine. Okay? Let's say the value of f at x or f of x, right? So far I've mentioned f of x, but we could also use the terminology the value of f, the value of the function at x, right? So the y value of the function at x, or f of x, to when we are using this notation. Okay. So given f of x equals 2x plus 3, whereas we used to write an equation, y equals 2x plus 3. Now we're saying, no, this is a function. So when I have a function machine that does 2x plus 3, well, what if my input is 6? What happens when I put a 6 into this function? Well, I would have 2 times 6 plus 3. So 12 plus 3 equals 15, right? So we could say, oh, f of 6 is 15. Well, what if instead the input is -2? So what if the input that we put into the machine is -2? Well, in that case, we multiply the input by 2 and add 3. So what's the first thing we do? We first multiply the input by 2 and then add 3. So f of -2, the value of the function at -2 is -1. Okay? Well, we can have an expression where we're actually putting in multiple inputs. Okay, well, what if my input is 3, but I'm also then subtracting the input, the output when x is 1? Okay, so first let's figure this out. What is f of 3? Okay, so we're still using the same function, right? Okay, so that means 2 times the input, 2 times 3, plus 3. Okay, 2 times 3 is 6, plus 3 equals 9. Great, but then we have another input. We have an input of 1. What is the value of the function at x is 1? Okay, so it's going to be 2 times 1 plus 3. 2 plus 3 equals 5. So now we can say, okay, so in this expression, we have that f of 3 is 9 minus, actually, let's follow the colors. F of 3 is 9 minus f of 1 is 5 over 7. Okay, so that's going to be 9 minus 5, 4 over 7. And so with this expression, I get 4 over 7. Now here's an ugly one. What if my input, right? What if my input is a variable with a coefficient? No problem. Now watch this, because I know this one really gets students. So if this is my input, all I do is I replace the x with the input. Okay, look what I just did. I find that students really struggle with this idea that the input could be just another variable. Okay, so I put 2a into the machine. Well, what do? Well, we multiply 2 times 2a. Oh, okay, so that's just 4a plus 3. Can I add 4a and 3? No. A constant and a variable cannot be added. That's all we can do. Okay, let's take it a step further. So now we're given a new function. We're given that a function is 7 times x plus 8, right? So now our machine has a different set of instructions. Whatever goes in has to be multiplied by 7, and then you add 8. so that we can get our output. Now, in this first example, what's the input? Ooh, gross. The input is negative x. Okay, so what do we do? So to start, I write the function without the x. Right? Watch this. In every single example, I just put blank brackets instead of the x. Okay, I'll get to that one later. And so wherever the input was, the x, what I replace what's in the brackets. So in this case, in the brackets, we have a negative x. In this case, in the brackets, we have a 4x. And so now we just follow the steps. 7 times negative x, well, that's negative 7x plus 8. Again, you cannot combine a term with a variable and a constant because they are not like terms. So this is as simplified as it gets. In this example, 7 times 4 is 28x plus 8. Again, these two terms are not like terms, so our output is a binomial. Input was a monomial, output was a binomial. Well, I wonder what happens when our input is a binomial. Okay, well, the first thing I'll do is I'll just write the function, and then I will add the input, x plus 2. What do I do? What do I do, Miss Sly? Ah! Well, we just follow our knowledge of algebra. So if you were to just look at this expression and I was to say simplify, what would be the first thing you do? Oh, well, I would expand using this distributive property, right? 7 times x, well, that's 7x. 7 times 2, well, that's 14. And then there's an 8 after. Do I multiply the 7 and the 8? No, they're not related. And now I simplify further. The 7x cannot be simplified. The 14 and the 8 can be added. So I get 7x plus 22. Okay. Well, what if the input is the same as it is in the function, but now there's a negative in front of the function sign? So if it's clearer, I might add some brackets here to say, oh, we're just taking the original function and multiplying it by -1. So I didn't change anything inside the function. The input is still the same. But what we're saying is once you get your output, multiply that by -1. So I get negative 7x minus 8, right? Each term is multiplied by a -1. Okay? And then what if our input is a fraction with a variable? Well, let's see. So once again, because the input is changing, I write the function as is, and the input is written as given, 2 over 3x. Okay, if we need to, so I see that I'm multiplying the 7 by the input. So if you need to, make the 7 into a fraction, multiply the numerators and the denominators. But I know by this point that the 7 is just multiplied into the numerator. So I get 14x over 3. Maybe I'll make it a shorter 14x over 3 plus 8. Remember, I feel like this might be, some people might think, oh, should I multiply the 7 and the 8? No, because the 7 is multiplying the bracket and then we're adding 8. Okay, we have a binomial. We can't simplify further. And in the last example, I see that my input, now remember, the input is just what is in the brackets. So what's my input? It's just the x squared. Well, how about the plus 6? Where does that go? Okay, so let's add some brackets to represent the function. Okay, the function is going to be in the purple square brackets. And part of the function is 7 times the input plus 8. And then what we're being told is, well, once you find the output, right, this whole thing is the output. Once you find the output, then can you please add a 6? Okay. So let's find the output. 7 times x squared, 7x squared, plus 8. That's my kitty cat, if you can hear her ringing her bell. Plus 6. And now we just simplify to 7x squared plus 14. Okay. Now, I hope you've checked the Brightspace announcements or the new tab for our unit, because you can see that I've announced our quiz that's coming up next week. And this lesson will be included on the quiz. Now, I know that we have a test coming up on Friday, but I really encourage you to do some homework, please, for this section, because it looks simple, or it might not. But for some of you might say, oh yeah, it looks simple. But then the quiz always gets students. So please, please, please practice these concepts. Thank you.